Okay, so now we're going to go over how do you create a graph using a table. So on this, it's already set up your x and your y axis. On your x is your time, counted by intervals of 10. And then on the y is your distance in meters at, again, intervals of 10. So now we're going to start by plotting. So I'm going to start with my first point, which is 0, 0, okay? So or 0, 30, I'm sorry. So on my time, I need to find 0. And at my distance, I need to find 30. And I'm going to place a point at 0, 30. Okay. And now I need to go to my next one. So my next one would be 10, 30. So my time is 10. And my distance is at 30 again. Okay. And now that I have this point, I can go ahead and I can connect these 2 points with a line, since this is a line graph. So my next point would be 20, 30. So my time should be 20 seconds, and my distance is 30 meters. I'm going to put my point, and I'm going to connect my last point with my current point. And then I go, and I'm at 30, 30. So time is 30, distance is 30. I'm going to place my point. I'm going to connect the dots with a line. My next would be 40, 30. So time is 40, distance is 30. I'm going to connect my 2 points. Next is 50, 30. So again, put my point. Time is 50, distance is 30. Connect it with a line. 60, 30 is my next point. Time is 60, distance is 30. Place my point and connect the 2. Next is 70, 30. My time is 70 seconds. My distance is 30 meters. Connect with the point. And the last is 80, 30. So over 80 on the time, up 30 on the distance, and connect my points. Okay. So now that I have my line on the graph, I can come down here to answer these 2 questions. So the first question is, describe the motion shown on the graph. We discussed this on Thursday of last week. So if you do not remember, you can go back to that numbers document, which is called distance time graphs, and you can look to see what type of motion this is. Now, if you look, this is a horizontal line. There's no diagonals, no nothing. It's just horizontal and straight and flat. So if it is flat, I know that there is no motion happening on this graph. So that is the type of motion that I'm going to put down. This is not moving. It is staying at the same distance for the entire time. And then the next, you're going to find the average speed. So now we're going to look down here at finding the average speed. Now we know that our average speed equals total distance divided by total time. So now we need to figure out what do we substitute. So I need to find what my total distance is and my total time. So we're going to start with our total distance first. So average speed equals, I'm going to find my total distance. So to find that, I'm going to look at my first distance and my last, and I'm going to subtract those 2. So the total distance is going to equal 30 meters, which is my last, minus 30 meters, which is my first, and that gives me 0 meters. So for this one, my total distance is 0 meters. And then I'm going to divide that by my total time. So same thing, when we did total distance, you're going to figure out your first and your last, and you're going to subtract those 2. So my total time will equal 80 seconds minus 0 seconds, which gives me 80. Now, if you start at 0, this is a lot easier, but on this one we started at 30, so we did have to go through this process. So since I start at 0, I have 80 seconds. And now I can divide that and I can answer with my units. So for this one, my average speed average speed equals 0, and then I need to take my 2 units, meters per second. Okay. If you have any questions, please make sure that you email us, and you can always rewatch this video as many times as you need.